Okay, we're going to start on 10.6b today. So chapter 10, section 6, and this is just the second half of that section. And we are looking at pyramids first. So a pyramid is a solid with one base and then sides that meet at a common point. So they come to a tippy top point called a vertex. Now remember we looked at prisms where there were two bases and then they met with the lateral sides, they connected. For pyramid, there's just that one base and then all the vertices go up in a slant to that vertex. So on a regular pyramid, the slant height, this is something that we have not talked about before, is the height of each lateral face. And it has to be from the vertex down, and it connects at a right angle with the base. So it's not the slant height up to the vertex. That would be too long, too big of a number. It's the slant from the very center of a side up to the vertex, and it makes that perpendicular line. So in this pyramid, the base is this square or rectangle down at the bottom. I'm not sure which one it is. So you have to be able to find what's that base and then find that slant height. Okay. And let's put a little arrow here that says that's the slant height. And let's also put a little arrow here to show what the vertex is on our pyramid. Okay, let's get some formulas going then. So surface area, we're just looking for those outside pieces. How much area is there? First thing we'd look at is the lateral area. And this is where they've taken it apart. So it's actually exactly shaped like this pyramid. There's that square base, and then there's the triangle that sticks up from that side, and the triangle from the other side, and the next side, and the next side. So it looks just like that pyramid, but flattened down. The lateral area, remember that's that capital L, equals 1/2 the capital P, remember that one? Perimeter. When we talk about the perimeter, we're talking about the perimeter of the base, that square at the bottom or whatever the base is. It's not always going to be a square. But for this one, we want the perimeter of this base, which then will give us, remember these kind of coincide with each other. So it gives us this side of this shape, perimeter of the base, times, now this is the curvy, slanty kind of L, like cursive, if you know cursive. I know that's a dying art, but it's a cursive L, which stands for the slant height, which we talked about just a second ago. So it would have to be from the center of the base up to the vertex, and it forms that right angle. That's our cursive L, or our slant height. We can even put a little arrow right there. That's the slant height. And then the perimeter gives us this outside edge here. So I'm going to put a capital P next to that. Okay, we will try this. We will try it. Once you know that, that's just the lateral area. So that's everything sticking up from the base. Then you've got to put the whole surface area together, which is equal to the lateral area, everything around that side, outside, plus the base. Okay, and our base we already talked about is that little piece sticking off the side. Okay, let's give it a shot. Find the lateral area and surface area of the pyramid, and we're going to just round to the 10th everything we do. So lateral area, first of all, what kind of base does this guy have? He's different than the one above. Looks like his base is this triangle down here at the bottom. So our base formula would have to be the formula for a triangle. And let's do lateral area first, equals 1/2 the perimeter times the slant height. Okay, can we figure out the perimeter for this triangle on the bottom, this base triangle. This side of the triangle's 10, this side of the triangle's 10, and this side of the triangle is also 10. So all three sides are 10. Let's put that in there. So perimeter 10 plus 10 plus 10 for that base triangle. And then we have to multiply it by the slant height. So they did show us what the slant height is. It goes up the side. One face is in the center. It meets the vertex and the base, and it forms a right angle. It is 10.4. So those are the numbers. We got the perimeter of the base triangle, the slant height, multiply that by 1. I don't have a calculator. Let's try it. So I'm going to add those. 10 plus 10 plus 10 is 30. And then 30 times 10.4. Oh, I didn't do that right. 30 times 10.4. Yep. And then half of that is 156. So I'd like for you to try that, put that in your calculator and make sure that you're putting it in correctly so that you get 156. If you don't add these together first, before you do your multiplying, you'll get a different answer. So this is one where you have to be careful to add those pieces that are inside the perimeter and get a perimeter number. Okay, so we have this part. We have this lateral area. Now we also need to know, to be able to put the surface area together, we need to know what the base is. So let's do that over here. Base equals, to find the area of this triangle that's our base, it's 1/2 little base times height. So don't get confused by that. The big B is a two-dimensional shape. It's that triangle at the bottom. The little b, we're just talking about if we were looking at that triangle. So I'm just going to draw the triangle from the bottom. Okay, and his base is 10, and then he has a height of 8.7. So the little b is just referring to the base of the triangle, the base of the base. So there are multiple b's here, but they mean different things. Let's go ahead and find that. So 1/2. The base of the triangle is 10, and the height of the triangle is 8.7. Just looking at the base of the pyramid, let's find that number. 10 times 8.7 in half, 43.5. 43.5. Okay, and that is also inches squared. Okay, we've got both pieces now. We're ready to put them together for the total surface area. So I'm going to put here surface, and we have to add the lateral area plus the base area. So 156 plus 43.5. And 199.5. 199.5 inches squared for the total surface area on that pyramid. Okay, I want you to pause your video and try this second one. Notice his base is not a triangle. You've got a square this time, so you'll have to do a little bit different formula to find the area of the base. Go ahead and pause and try. All right, let's look. So the lateral area, 1/2 the perimeter times the slant height. And it's a square, so 8, 8, 8, 8 all the way around. 1/2. 8 plus 8 plus 8 plus 8. 8 times 4 is 32. Right? And the slant height, they told us, is 10.8. Let's find that number. 32 times 10.8. Good. Divided by 2. Did you get 172.8 inches squared for the lateral surface area? The base is a square, so we would do, you could say length times width, or you might say side times side, side squared, something like that for a square is 8 times 8 or 64 inches squared. Lateral base, let's put them together. So the surface area of the whole thing, lateral plus base, 172.8 plus 64. Let's see if we match 236.8. Yay! 0.8 inches squared. Okay, that's a pyramid. That's how you find the surface area of a pyramid. Let's turn it over and we'll try a cone. Okay, now you're probably thinking this is very similar to a pyramid, right? And it is. We have a base and then the sides come up to, what do you think that tippy top part is called? It is. It has a solid circular base and a vertex. So just like a pyramid, except that the base is a circle. On a cone, the slant height, we're going to use that again, is the distance from the base to the vertex. So it could be that line right there going from the base up to the vertex. And we'll still use that cursive L to describe that. The base down here is that circle in the middle, and the base edge is where it connects to the lateral side. Ooh, I'm spelling edge wrong. Edge. Okay. All right. So this was the vertex. All these little vocabulary words you get to work with. So let's try this. This is the net for it. When you take it apart and flatten it out, there's our base, that big circle, and then they rolled out the sides. So these would connect all the way around the circle. But if we roll them out, it kind of looks like a quarter of a circle, kind of like a pie piece. Or remember we did sectors? It's like a sector of a circle. Okay, lateral area equals, this is interesting, pi. You know, every time there's round stuff going on, we got to put pi in there. Pi times the radius times, what does that cursive L mean? Yeah, exactly. Okay, so we need to know the radius of the circle. And then the slant height is a line connecting the vertex to the base. So on a net, it would be found right there. Okay, and let's write on here again, slant height, just in case you're looking at this later and thinking, I don't remember what that is, and you don't think to turn the paper over, we'll have it written on both sides. Do we need to write radius too? Just in case. Oops, it's always better to have it written on there for your notes. Okay. So this is how you find the lateral area. The surface area, then, you take that lateral area, and what do you think we need to add? What have we not put in there? The base again. Yep. So it's really similar to the pyramid on the front. Find the lateral area, find the base, put the two together. Let's try this. Number 5, it says find the lateral area and the surface area of the cone, and then rounding to the nearest tenth. So lateral area is pi times the radius times the slant height. So pi, now did they give us a radius? Oops, I put equals. They did right there. 9 is the radius of that circle, so we'll plug that in. And then the slant height is from the edge to the vertex, and they did not give us that number. Instead, they told us how tall it is from the center of the circle. That's a different measurement. We don't actually need that one for this, except it would help us to find our slant height. So if you look at that for a second, do you see a familiar shape in here that we can use to find that outside slant height? Yeah, we're getting a little fuzzy. Okay, I see a triangle, and we've done this, right? We know what to do. I'm going to pull the triangle out. It's got a right angle there. Connect the base to the vertex. This side's 9, this side's 12, and that's the hypotenuse. Okay, so we can do this. We would say 9 squared plus 12 squared equals c squared. And then that would be 81 plus 144 equals c squared. Let's put those together. I know you guys are good with Pythagorean. 225 equals c squared. And we don't want c squared, so we're going to take the square root of everything. And we get 15 is our c, this outside, which is our slant height that we were looking for, 15. So you might have to do that. I think on the assignment, there's one where they give you the slant height, and then there's 2 or 3 where they say the height of the pyramid from that center. So you will have to use Pythagorean to get some of that. All right, pi times 9 times 15, 424.1 centimeters squared for the lateral height. So that's everything around like the cone part of it, but not the base. Base, it's a circle. What is the formula to find the area of a circle? Okay, hopefully you're yelling pi r squared. Okay, that is right. Pi, and we already figured out that the radius was 9. So pi times 9 squared. You should get 254.5 centimeters squared. Okay, we've got the upper part, the base part. Let's put them together. Surface L plus B, 424.1 plus 254.5. How much surface area does this cone have? 678.6. And those are centimeters, and they are squared, 2-directional. Okay, we've got one more. This one's for you to try. I noticed they didn't give you the slant height, so you'll have to think about that. How can you get that slant height? Pause your video and try that, and then come back. All right, let's see. Lateral, pi times r times the slant height. And if we pull that triangle out, this side's 12, this side's 5. What's c? Because c is the slant height, and that's what we need. So I'm going to do a little work over here. 12 squared plus 5 squared is the hypotenuse squared. So 144 plus 25 equals the hypotenuse squared. 169, and if we take the square root of 169 is 13. So I know now that my slant height is 13, it's inches. Okay, then I've got all my pieces. Pi, radius is 5, slant height is 13. What'd you get when you put that together? 7 times 5 times 13, or pi times 5 times 13. 204.2 inches squared. All right, base. So we're looking at the circle now. Pi r squared. Our radius is 5. So we get 78.5 inches squared. Okay, we got all our pieces. Let's put them together. Surface, lateral plus base, 204.2 plus 78.5. Did you get 282.7 inches squared? Done, we did it. All right, so you know now how to do pyramids and how to do cones. You get started on that assignment, and we'll see ya.